In previous classes, we discussed ray diagrams for concave mirror and convex mirror. In this class, we will solve some problems based on mirror formula and magnification formula. Okay, let me read the problem. Find the distance of the image when an object is placed on the principal axis at a distance of 10 centimeters in front of a concave mirror whose radius of curvature is 8 centimeters. So in problem, he is asking distance of the image, but the object distance is given and the radius of curvature is also given, and here concave mirror is given. Let me draw the concave mirror. This is concave pole, focus and center of curvature. So radius of curvature is given. The distance of center of curvature from the pole is called radius of curvature. Radius of curvature is given. It is denoted by capital R. Capital R equals to 8 centimeters. And the object distance is given, that is 10 centimeters. So observe diagram. The radius of curvature is 8 centimeters. It is the distance from the mirror to the center of curvature. Our object distance is 10 centimeters. Definitely it should be placed beyond center of curvature. Let me take distance of the object from the mirror is 10 centimeters. U equals to 10 centimeters. The distance of focus from the mirror is called focal length. Let me take the distance of the focus from the pole is called focal length. Focal length. But focal length is not given in the problem. But we know the relation between focal length and the radius of curvature. That is, you can observe clearly the diagram. Focal length, the distance of a focus from the pole is focal length. The distance of center of curvature from the pole is called radius of curvature. So you see carefully. Focal length is half of the radius of curvature. Focal length is half of the radius of curvature. So radius of curvature is 8 centimeters divided by 2. 2 ones are 2 fours. So focal length is 4 centimeters. So now write the 4 centimeters. So we know mirror's formula. Mirror's formula. That is 1 by focal length equal to 1 by image distance plus 1 by object distance. We have to find image distance. 1 by V equals to 1 by U, bring this side, 1 by F minus 1 by U. When we are going to solve the problem, when we are going to apply the values in mirror formula as well as in magnification formula, every time we have to apply the sign conventions. For that, we have a trick. So every distance should be compared with the incident ray. Every distance should be compared with the incident ray for sign conventions. All distances are measured from the mirror. All distances are measured from the mirror, and every distance should be compared with the incident ray. Let me draw the incident ray. The direction of incident ray always towards the mirror. It is denoted by I. Now come to the object distance. The direction of object distance towards left and the direction of incident ray towards right. Both are in opposite direction. Then consider negative. Here, sign conventions. Sign convention. U will become negative because incident ray and the direction of object distance both are in opposite directions. So then consider negative. U is negative minus 10 centimeters. Now come to the focal length. So focal length is also measured from the mirror only. So the direction of focal length is towards left and the direction of incident ray towards right. Both are in opposite direction. Then consider negative. So focal length is also negative minus 4 centimeters. Now substitute the values. 1 by V equal to 1 by focal length is minus 4 centimeters and minus 1 by U is minus 10 centimeters. Minus 10 centimeters. Now 1 by V equal to minus 1 by 4 and minus into minus plus 1 by 10. Write first positive value. So 1 by V equals to 1 by 10 minus 1 by 4. Now take LCM. 1 by V equals to, take LCM, 10 and 4. 2 5s are 10, 2 2s are 4. 2 5s are 10, 10 2s are 20. LCM is 20. So divide 20 by 10. 10 2s are 20, 2 1s are 2. Minus divide 20 by 4. 4 5s are 20 and 5 multiply 1. 5 1s are 5. 1 by V equals to 2 minus 5. Plus into minus minus. So 2 minus 5, 3. Minus 3. Minus 3 divided by 20. But we need distance of the image. But here 1 by V. Then V equals to, this fraction becomes reciprocal. Now you can write 20 by 3. Now you can cancel. 3 1s are 3 6s are 3 6s are 18. Remains 2. Take decimal. It becomes 20. Again 3 6s are 18. Remains 2. Already decimal is taken. It becomes 20. Again 3 6s are. So take 2 digits after decimal. Enough. So now V equals to minus 6.66 centimeters. This is the distance of the image from the mirror. So definitely you can observe this negative sign denotes a real image. This negative sign denotes image is formed in front of the mirror, that is a real. Our image is a real image. Observe the value. It is 6.66. So radius of curvature is 8 centimeters and definitely a focal length is 4 centimeters at here, and the radius of curvature 8 centimeters at here, and definitely 6.66 lies in between center of curvature and focus. Maybe your image is going to be formed here. Our common sense will tell us when object placed beyond center of curvature, definitely image is going to be formed in front of the mirror in between center of curvature and focus. So our image distance is 6.66 centimeters. Definitely it lies in between center of curvature and focus. So this is the first problem. Let us do second problem. So we solved the first problem. So let us solve second problem. Let me read the problem. A convex mirror with a radius of curvature 3 meters. Radius of curvature is given in the problem. This is 3 meters. Is used as a rear view mirror for vehicle. If a bus is located at 5 meters, so here bus will become object distance, that is 5 meters is given in the problem. From this mirror, find the position, nature and size of the image. So convex mirror is given. So let me draw the diagram, you can understand. Convex mirror, curved outward reflecting surface, pole, focus and center of curvature. So radius of curvature is 3 meters. The radius of curvature is the distance of center of curvature from the mirror. So every distance should be measured from the mirror. So that's why I have taken from the mirror to the center of curvature, the direction of arrow towards right. So R equals to 3 meters. Now here bus is located at 5 meters from this mirror. So every time object should be placed in front of the mirror. So our bus object is placed in front of the mirror at 5 meters distance. Every distance should be measured from the mirror. So the direction of object distance towards left. So that is U equals to 5 meters. 5 meters. Now this time also we can use mirror formula. Let me write the mirror formula. That is mirror formula. 1 by F equals to 1 by V plus 1 by U. So before going to substitute the values, we have to apply the sign convention. So for that, every distance should be compared with incident ray. So let me take incident ray always towards the mirror. So the direction of incident ray towards right and the direction of object distance towards left, both are in opposite direction. Then consider negative. Here, sign conventions. Sign convention. You consider negative because incident ray and the direction of object distance both are in opposite direction. So U is minus 5 meters. Now come to the focal length. Focal length is not given in the problem. Already I said. So focal length is the distance of focus from the mirror. Every distance should be measured from the mirror only. So this is a focal length. So focal length is half of the radius of curvature. So focal length equals to radius of curvature divided by 2. Focal length is radius of curvature 3 meters and divided by 2. So here focal length is 3 by 2. 3 by 2. You can observe the direction of incident ray and the direction of focal length both are in same direction. Then consider positive. Focal length is positive plus 3 by 2 meters. Now substitute the values in mirror formula. We have to find distance of image. So 1 by V equals to, bring 1 by U this side. 1 by F minus 1 by U. Now 1 by V equals to F plus 3 by 2, 1 by and 3 by 2, and minus 1 by U minus 5 meters. So minus 1 by V equals to, fraction by fraction, it becomes reciprocal. It becomes 2 by 3. And minus into minus plus, plus 1 by 5. Now take LCM. 3 5s are 15. Divide 15 by 3. 3 5s are 5 2s are 10. And plus divide 15 by 5. 5 3s are 3 1s are 3. So 1 by V equals to 10 plus 3, 13 divided by 15. If you cancel it, 1 by V equals to 13 by 15. 15. So, but we need distance of image. V equals to 15 by 13. 15 by 13. 13 ones are 13. Remains 2. Take decimal. It becomes 20. Again 13 ones are 13. Remains 7. All our decimal is taken. It becomes 70. 13 5s are 65. You can cancel it. So take two decimals, take 2 digits after decimal. Okay, now we found the distance of image. In the problem, he is asking nature and the size of the image. For that, we have to use magnification formula. Already we discussed the magnification formula. That is M equals to height of the image divided by height of the object equals to minus distance of the image divided by distance of the object. So image height and object height is not mentioned in the problem. Just neglect it and take it. So now magnification equals to minus V divided by U. U is given, and but we found image distance. We found V and U is given in the problem. So when we are going to apply the values in magnification also, we have to apply sign convention again. So sign convention. So already we found, so take U. The direction of object distance towards left, the direction of incident ray towards right, both are in opposite direction, then you consider negative, minus 5 centimeters. Now apply, now substitute the values. M equals to minus V, how much? Take a fraction, 15. 15 divided by 13 and divided by U minus 5. fraction by fraction. So reciprocal. Magnification equals to minus 15 by 13 into and 1 by minus 5. Ever there in the denominator, it becomes reverse. It becomes 1 by minus 5. So now 5 ones are 5 threes are can cancel. M equals to minus into minus plus 3 by 13. 3 by 13. Now cancel. 0 point. It becomes 30. 13 twos are 26 and remains 4. Decimal taken. It becomes 40. 13 threes are 39. Get cancelled. So we got magnification equals to 0.23. Already I told you, when magnification is given, we have to observe individual. So here M is positive. M is positive and M is M equals to 0.23. Definitely it should be less than 1. M is less than 1. When M is positive, that image is virtual image. Virtual image. All virtual images are erect. That means upright images. Erect image. When M is less than 1, that image is a diminished. Diminished image. So small in size. When M equals to 1, the image size is equal to the object size. When M is greater than 1, that image is enlarged or magnified. When M is less than 1, that image is diminished. Diminished. Here we found nature and size also. So nature of the image is that image is virtual, that image is erect, that image is diminished. So finally, we discussed in previous classes, convex mirror always can form virtual and diminished images. Let the object be placed anywhere in front of the convex mirror, always image is going to be formed behind. So let the object be placed anywhere in front of the mirror. Your image is always going to be formed behind the. Let me check whether it is formed between pole or focus. So our our image distance is 1.15 meters. 1.15 meters. If you cancel it, you will get it. So 1.15, our image distance. Definitely up to focus 1.5. Up to focus 1.5. So we got 1.1. Up to focus 1.5 because the radius of curvature is 3 meters. So radius of focal length is half of the radius of curvature. So 1.5. Our image is 1.15. So definitely it should be formed here. Yeah, we got the image behind the mirror in between pole and focus. So this is the way of solving the problems in reflection of light at curved surfaces. This is our last class from the reflection of light at curved surfaces. Our chapter is finished.